Imagine a world where computers could solve problems in seconds that would take today's machines billions of years. Picture unhackable communication networks, impossible to eavesdrop on. This is the promise of quantum technology, a revolution already unfolding around us. It's not science fiction. It's the very real science behind the smartphones in our hands, the medical scanners in our hospitals, and increasingly, the security that safeguards our digital lives. Quantum physics, often considered intimidating and complex, governs the universe at its smallest scales. It describes a realm where particles can be in two places at once, where information travels instantaneously across vast distances, defying our everyday intuitions. This strange, almost magical world holds the key to unlocking unprecedented technological advancements, including a new era of cybersecurity. As our reliance on the internet grows, so too does the need to protect sensitive data from increasingly sophisticated cyber attacks. Traditional cybersecurity measures, while robust, are ultimately vulnerable. Quantum physics, however, offers a solution, a way to secure our digital lives by harnessing the very laws of nature. This is where the bizarre phenomenon of quantum entanglement comes into play. Entanglement, famously dubbed spooky action at a distance by Albert Einstein, is one of the most baffling yet powerful concepts in quantum mechanics. Imagine two particles linked in such a way that they share the same fate, no matter how far apart they are. Change the state of one, and the other instantly mirrors that change, even if they're light years apart. This instant connection forms the bedrock of quantum entanglement. Think of two coins flipped simultaneously. If one lands on heads, we know instantly the other must be tails. This is a classic example of correlation, but with entangled particles, the connection is far deeper. It's as if the coins themselves don't decide their state, heads or tails, until one is observed, at which point its entangled partner instantly assumes the opposite state. This seemingly impossible connection, verified countless times in experiments, has profound implications for security. If someone tries to intercept entangled particles to eavesdrop on a communication, the very act of observation disrupts the entanglement, alerting the intended recipients to the intrusion. This unique characteristic makes entanglement-based communication exceptionally secure. Today's cybersecurity relies on complex mathematical algorithms to encrypt data, making it unreadable to anyone without the correct decryption key. Yet, as computing power increases, particularly with the looming arrival of powerful quantum computers, these encryptions become vulnerable to brute force attacks. Imagine a thief trying to crack a safe with thousands of possible combinations. A traditional computer is like trying each combination one by one. A quantum computer, however, could try all combinations simultaneously, making short work of even the most complex codes. This poses a significant threat to our current digital infrastructure, potentially exposing sensitive financial, medical, and governmental data to malicious actors. The limitations of our current cybersecurity methods are becoming increasingly clear. As we transmit more and more sensitive data online, the need for a fundamentally different approach to security grows more urgent. Quantum entanglement, with its inherent ability to detect eavesdropping, offers a compelling solution, a way to build truly unhackable communication networks. Section 4. Quantum keys, unbreakable locks, for the digital age. One of the most promising applications of entanglement in cybersecurity is quantum key distribution, or QKD. This technique allows two parties to share a secret encryption key, the digital equivalent of a one-time pad, used only once and then discarded. The beauty of QKD lies in its ability to reveal any attempt to intercept the key. Imagine sending a stream of polarized photons, particles of light, each representing a bit of information, 0 or 1, depending on their polarization. By encoding these photons using randomly chosen entangled pairs, any attempt to intercept and measure them would inevitably disturb their state, alerting the sender and receiver to the breach. This inherent security stems from the very nature of quantum mechanics. Any attempt to observe a quantum system inevitably alters it, making eavesdropping on a QKD exchange fundamentally impossible without detection. This makes QKD a game-changer in cybersecurity, offering a level of security unmatched by any classical technique. Section 5. A quantum future, secure communications, closer than we think. While still in its early stages, QKD is rapidly moving from the realm of theoretical physics to practical applications. Across the globe, pilot projects are underway, testing and implementing this revolutionary technology. Banks are using QKD to secure financial transactions, governments are exploring its potential for secure communications, and research institutions are pushing the boundaries of its capabilities. In China, a dedicated quantum communication network already stretches thousands of kilometers, connecting Beijing to Shanghai with unhackable links. In Europe, research initiatives are developing satellite-based QKD systems, paving the way for global quantum communication networks. These real-world implementations demonstrate the potential of QKD to revolutionize cybersecurity as we know it. Challenges remain, however. Building large-scale, cost-effective quantum networks is a complex undertaking. Maintaining the fragile entanglement of photons over long distances requires sophisticated equipment and error correction techniques. Yet, the rapid pace of advancements in quantum technology suggests that these hurdles are surmountable. We stand on the cusp of a new era in cybersecurity, one where the seemingly bizarre laws of quantum mechanics safeguard our digital lives. While challenges remain, the promise of unhackable communication, secured by the fundamental laws of nature, is too great to ignore. As research progresses and technology matures, quantum-secure networks will become increasingly commonplace, ushering in a future where our data is truly safe, protected by the very fabric of the universe itself.